Welcome to the Lighthearted Academy. Today we're continuing our trigonometry lessons in trigonometry lesson number 30. We are in the part where we're talking about the graphs of trig functions, especially we're talking about the trigs for graphs of sine functions and cosine functions. Now the sine function and cosine functions, they're called sinusoidal functions because they have the same form, and then the sine and cosine functions are very interesting functions because they can be used to model a lot of real physical phenomena and scientific phenomena. For example, like music sound waves, light waves, periodic phenomena like the periods of the moon around the earth, the temperature cycles, a lot of things that we can use to model. We can use, a lot of the physical phenomena. They are periodic. We can use sine and cosine functions, sinusoidal functions, to approximate them and to model them. Now, our modeling here today that we're going to be looking at is going to be rough estimates. We're not going to be able to get an exact 100% matching model. To do that, you will need more complicated equations. But right now, our basic equation, right? If you remember from last classes, our basic equation is a times sine bx minus c times plus d. So we have four numbers here we can play around with. For the lack of any better terms, I think there should be an actual term for those numbers. But each of them, can affect the amplitude. This A affects the amplitude, B affects the frequency and the period, C affects the phase shift, and D affects the vertical shift. So all those numbers play around. We can play around with those numbers to match the data that we're given. So in this section, in today's lesson, we're trying to see how we can do that. How do we match the data? How do we come up with the number A, B, C, and D that will match the data that are given, a periodic phenomena that we're given, So that's the goal of today's lesson. Alright, let's look at this first example. Throughout the day, the depth of water at the end of the dock varies with the tides. So we're talking about the tidal phenomena, which is periodic. The table shows the depths in meters at various times during the morning. Find the sinusoidal equation that models this data. Alright, now if you have ever gone out fishing, or if you know about the ocean, tides are periodical phenomena. Usually you have 2 high tides in a day and 2 low tides in a day. So the tidal cycle is about 12 hours a day. 12 hours. The cycle is about 12 hours per 24-hour period. So usually go through 2 periods within a day. But let's go ahead and see how that plays into it. Now, look at the data. T is the time, and we're given the actual time from midnight all the way to noon, 12 a.m. all the way to 12 p.m. And here we have the depth of the tide, depth of the dock, measured from the dock. At 2.55 meters, it increases to 4.4 meters. Then it starts to decrease all the way down to 1.80 meters, and then come back out a little bit at 2.27 meters. Alright, so we want to go ahead and determine the numbers that will allow us to model this phenomenon, model the data. Now the first thing we want to do is model the amplitude. Now find out what A is. Now A would be the maximum value minus the minimum value divided by 2. So if you look at this data, which number is the maximum? As far as we can tell, 4.4 is the maximum, and the minimum, as far as we can tell, is 1.8 at 10 a.m. So we subtract it and divide by 2. So this will give us 2.6 divided by 2, which is 1.3. So this tells us that the amplitude probably will be 1.3. The amplitude will be 1.3 because it will be the absolute value of A. So A will be 1.3, Now, another more important thing is this. Let me go ahead and put amplitude, but this is not exactly amplitude yet, Because whether we are going to decide what the A is, whether A is positive, is going to be positive or negative depends on what function we're going to use. And we will talk about in a minute what function we're going to choose, whether we choose sine or cosine, because both sine and cosine can be possible. Now, it is important to determine what the midline is, the average value. So the midline is maximum plus minimum divided by 2, which is the average of the maximum and minimum. So we're going to do 4.4 plus 1.8 divided by 2. So that will give us 6.2 divided by 2 is going to be 3.1. So what it tells us, this is the average value. The 3.1 meters, the average height, average depth of the dark from 12 a.m. to 12 p.m. That's basically the middle. What's the middle value is going to be? All right, so we got A, we got D. Now it's time to get B and C. But in order to determine B, okay, we have to understand how do I find the period? Well, in order to count the period, we can count from maximum to maximum, but we don't know when the next time maximum comes. We don't know. We can that's one period, or from minimum to minimum, but we don't know when is the time it hits the minimum first, before 10 a.m. Okay, so we can't do that. But we know from maximum to minimum, that should be half of a period. So the time from maximum to minimum should be half. Okay, and how long does it take from maximum to minimum? It reaches maximum at 4 a.m. and it reaches the minimum at 10 a.m. So it took 6 hours, right? So that should be twice of the period. So it's 10 minus 4, which is 6 hours. 6 times 2 will be 12. So this will be 12 hours. Okay, so that means the period is 12 hours, and which it makes sense because as our understanding of time is, it takes 12 hours for a tide to complete one cycle. In any 24-hour period, there should be 2 tides, or it can go up 1 maximum, 1 minute, things like that. So period is 2. So what is B equal to? B is always equal to 2 pi over P, the period. Because in sinusoidal functions, sine and cosine, their original period, their natural period is 2 pi. But this period is not 2 pi, so we have to take into consideration of that. So it's 12 divided by 2 pi divided by 12, which is, you can reduce that as pi over 6. So B should be equal to pi over 6. Okay, now let's go ahead and talk about the phase shift. Now if you remember, the phase shift is equal to C over B. So this is where you want to start. Okay, now where do you want to start depends on which function you want to use. Now looking at this, okay, first of all, if we want to start with sine functions start with the midline. And the midline is a 3.1 meter in this case. But as you can see from the table, it's very hard to determine when does the tide hit 3.1 meters. I know the tide hits 3.1 meter probably somewhere between 12 a.m. and 2 a.m., but I can't say exactly when. It hits 3.1 again when it dropped down from 6 to 8, right? Between 6 and 8 a.m. it dropped from 3.8 to 2.55. So I know the tide must hit 3.1 somewhere here. But it's very difficult to do that. So what we can do is, if we choose cosine though, we can start with the maximum or the minimum. And I think we can, it's probably better to start with a maximum using cosine. So let's use the cosine function, and then we're going to start with 4 a.m. as our beginning. So we're going to start with 4. So that means we're not going to start with 12 a.m. 0. Time equal to 0, we're going to start with time equal to 4. So that means C is equal to 4B, and we already know what B is. So C is going to be 4 pi over 6, and you can reduce that to 2 pi over 3. Okay? So, as I mentioned already, we are going to use in cosine, right? So now, I think we have everything we need. Because we started at the maximum for cosine, so the initial, the A value should be positive, and we're still using cosine function. And our B is pi over 6 t, okay, B over 6 pi over 6 t, because our independent variable is time, is t here, minus 2 pi over 3. Now why is it minus? Because we shifted to the right 4 units, basically 4 hours. And then our vertical shift is 3.1. So that is the correct function to model this data, okay, using what we have talked about. But this is not going to be an exact model. And also, there's more than one answer. I could use sine, or I could use cosine, but start with 8 a.m. But if I use 10 a.m., if I use 10 a.m., that's the minimum value, and I would put a negative 1.3 in front. But the B number will be the same, but the C number will be different. It would be 10 pi over 6. Okay, as you can see, we can shift differently. I can even shift backwards to the hours before 0. Okay, shift left side. If I shift left side, then this number will be a negative, then here would become positive. Okay, alright, so hopefully that's clear on this. So let's go ahead and try another example here. Now, this is This table gives us normal daily high temperatures for the city of Chicago. I think this is the actual data in degrees Fahrenheit for month T. So T1 equal to January, so we start from 1 and go all the way to December. So the next month 13 would be January again. So we want to find the sinusoidal equation to model the data. Alright, so again, let's not decide what function to use yet, because we don't know whether we want to use sine or cosine. Alright, but let me just go ahead and put the original model on here. So it's a times sine bx minus c plus d. So this is going to be our model that we want to use. Alright, so let's identify the maximum value, the maximum or the minimum value and maximum value. So the maximum seems to be happening in July, 83.7 degrees, and the minimum happened in January, 29.0 degrees. Okay, alright. So let's find the amplitude. Amplitude is A, or is maximum minus minimum, divide by 2. So that will be 83.7 minus 29.0 divided by 2. So that will give us, let's take a look. That will give us 27.35. Okay, it's measured in degrees. Now our midline will be the maximum plus the minimum divided by 2 is like the average value. So it will be 87.3 plus 29.0 divided by 2. So let's type in the calculator. 83.7 plus 29 divided by 2, so that will give us 56.35. Okay, alright, so that's the amplitude, that's the midline. Okay, then let's determine the period. Now again, the previous example, we see that the period will be half the time from twice the time from minimum to maximum or maximum to minimum, or it will be the time from maximum to maximum. Now as you can see, we can count, right? From July is the month, and then until the next time it hits maximum, it will be July again. So the 12 period should be 12 month. So in this case, it should be 12 month. Okay, 12 month. And 12 months makes sense because we are talking about temperature cycle. So the maximum, if the maximum occurs in July, it wouldn't be another 12 months until we hit the maximum again. Okay, so period is 12 months. So what would B be? B would be 2 pi, the natural period for sine and cosine, divided by P. So it's 2 pi over 12. So this would be pi over 6 again. Okay, pi over 6. Alright, then we just have to figure out C and C. In order to figure out C, we have to decide what function we want to use. Do we want to use sine? Well, take a look at this. The midline, sine always starts with a midline, so 56.35. Now, it's not very possible because we don't have 56.35 here. 56.35 is probably approximately in April, or approximately in somewhere in October, between October and November, but we don't know what day is, so it's going to be hard. So let's start with either January or start with July. Okay. Now, last time we started with the maximum. Last example, I started with maximum. So this time, let me start with the minimum. So we're going to use the cosine function. Okay, we're going to use cosine and start at minimum. Start at minimum. Now our phase shift. Okay, so phase shift is equal to C over B is equal to 1. So that means C is equal to pi over 6 because C is equal to 1 times B, so it's pi over 6. Okay, so we will have that pi over 6 in there. Alright, so now our function is going to be negative 27.35. Now why do I have to start with negative 27.35? Because I started with a minimum value. And you remember cosine, if I start with cosine like this, start with a minimum, then that means it's an opposite of a regular cosine, because regular cosine starts with like this, with the top on maximum and ends up in maximum. If I start with minimum, negative minimum, that would be a negative cosine. This would be a positive cosine. Okay, so that's why it's important to remember the pattern of the cosine and sine. So I'm going to use cosine. B is going to be pi over 6 x, okay, or t. Let's go to use t. Pi over 6t minus pi over 6, okay, plus 56.35. So this equation should be able to model this. data. Now, however, it's not going to be a perfect model. It will probably only model the January and then July temperature. It might miss the temperatures in the middle, depending on what kind of curve it is. In advanced mathematics, you can learn how to actually model that with a better model. But then we have to have a lot more variables and inputs and things like that. All right. So far, we only have 4 things that we are controlling. Okay. Alright, so hopefully this lesson is instructive, and please leave any questions and comments in the comment sections, and please subscribe and recommend it to your friends and students, fellow students who are struggling on trig, and hopefully we can provide more lessons, instructions, and tutorials for all of you to help you along the way in learning trigonometry. Alright, thank you, and we'll see you next time.